Okay, so yesterday we talked about angle bisectors. Well, today, what if the bisector is not perpendicular? Well, this is where we talk about medians. So, a median of a triangle um, is the segment formed by connecting the vertex to the midpoint of the opposite side. So, the vertex is your point of your angle. So, if I were to draw a triangle like so, and let's say this is A, B, and C, and we'll pick the vertex starting at A, and we want to go to the middle. So here, assuming that this B and C are congruent, I'll call this point D. So if I connect this, uh, D is then the uh, the median, or we can also say AD is our median, is the median in this scenario right here. Uh, Next, the point where all three medians intersect. So that is called a centroid. Let's draw a picture of another triangle. So let's call this triangle here, here, here. And we'll say A, B, C. And I'm going to find all the medians here. Let's say here, this is the medians, because all these sides are going to be the same. So this side is congruent to that side, and this is congruent to that, and this is also congruent to that. And we'll call this the medians X, Y, Z. Now we connect the vertex to the medians. So let's do this to all the vertexes, to all the medians. Like so. This point here in this middle, this point right there, we'll call that point D. Our D, our centroid, is D, like that. Our centroid theorem states that the centroid is of a triangle is 2/3 the distance of each vertex to the midpoint of the opposite sides. So what does that really mean? So if I drew another picture, we love pictures here, and so if I say let's draw this kind of picture again, A, B, C, and this, that, and that, and this is congruent like so, and this is centroid, and we'll call this centroid D. It basically says that, we'll say X, Y, Z basically says that it breaks this entire thing up into thirds. So if AY, if the whole distance is, let's say AY equals, we'll say 6, then we break up 6 into thirds. So that's 6 divided by 3 is 2. So this dy must then equal 2. So this is actually 2. And then this has to be 4, because 4 plus 2. And 4 is 2/3. So they're saying that from the vertex, from A to D, from the vertex to the median, to the centroid, that has to be 2/3 of the entire length. The entire length being 6, 2/3 of 6 being 4. I find the easiest way is to kind of break everything, all the segments up into thirds, and then you can figure out, well, the 1/3 is on the bottom, and the thing from the vertex to the centroid is 2/3. Okay, so we want to split our entire median into what 3 pieces, right? Into thirds, and 2 of the pieces will go from the vertex to the centroid, and 1 of the piece will go from the centroid to the midpoint. So let's try some of this. Let's use some of this in our practice. So BE and ED, find BE, BD. Given that, so this is all centroids. Given that BD, so the entire distance is 24. So I'm going to take 24 and I'm going to divide that by 3 so that I know what the thirds are. So I'm going to take 24, divide that by 3, and I got 8. So I have an 8 plus 8 plus 8 for the entire distance. Well, a third of that, which is 8, will be down here. And the other 2/3, which is 8 plus 8, which is 16, is up here. So BD is 24, so BE must equal 16. BE is 16. And ED equals 8. Let's do the next example. Find PQ and PN if QN equals 20. So QN equals 20. So this right here, if I draw that here, is 20. Well, QN is the distance between the centroid to the vertex. So PN, so I'm going to take, so imagine PN, and this whole entire PN is blocked up into thirds. And QN is 20. So there's 2 segments to make QN. If I take 20 and I break it into half, then this is 10 and 10, right? Because the entire distance of QN is 20. So now I know the last one has to be 10. So I know PQ has to equal 10, and PN has to equal the entire thing, which is 30. I find drawing a picture makes it easier for me to figure it out. So let's see here. Next example, JG, so and KG. Given that JK, so JK is right here, this is 4. That is the bottom part, the one that's from the centroid to the median. So if I drew the entire chunks, right, JG is here, and it is breaking up into thirds. JK is that bottom part, so it is that small part, so it is the 4th. So each part is going to be 4, so 4 and 4 and 4. So KG should equal 8. 4 plus 4 is 8. And JG should be 4 plus 4 plus 4, or 4 times 3, which is 12. Okay. E is the centroid of ABC, okay? And BE equals 12. So this part here, from the central vertex to the centroid. So here, if I drew a picture, if I did B and B here, and I broke this up into thirds, E would be here because that's the bottom half. That is my centroid. It is a third down. And they say BE, the entire thing, is 12. Well, I just got to break 12 up into halves. 12 divided by 2 is 6. So this is 6 and 6. And then that last part, so that also then be 6. So now I know that BD is the entire distance. That's 6 plus 6 plus 6, or 6 times 3. That's 18. ED is then just 6. Lastly, number 5 on this is T is the centroid, triangle PQR, okay. PS, so the entire thing is 33, okay. So PS is 33. So if I break this down, and I know T is my centroid, that means that's on the bottom the S is on the median, so my T is here. The entire thing's 33, so I just take 33 divided by 3. That gives me 11. So this is 11, 11, and 11. Well, then PT is 2 of these. 11 plus 11 is 22. And PS, well, we already got PS. The ST is this last segment here, which is just 11.